South America built a predator without teeth. Not a dinosaur, not a mammal, a bird. And for millions of years, that bird tested how far a skull, a neck, and two running legs could go. The animals we call terror birds are often imagined as monsters. Giant beaks, long legs, a silhouette built for fear. But that image is too simple. It turns a real evolutionary experiment into a creature from a nightmare. The more interesting truth is stranger. These were birds, relatives in the broadest sense, of a living world of feathers, beaks, balance, breathing, and motion. But in parts of ancient South America, flight was no longer the main question. The sky was not where the experiment was happening. The ground was. After the age of non-avian dinosaurs ended, South America became a separate arena for evolution. Its mammals, reptiles, landscapes, and predators developed for long stretches of time with their own rules. In that world, a lineage of birds moved into a role that most people do not expect from birds at all. Large terrestrial predators. They did not solve that problem with teeth. They did not solve it with grasping arms. They did not solve it with claws. They solved it with a body plan that was already bird-like, then pushed it toward a very different task. The skull became the striking tool. The neck became the delivery system. The legs became the platform. The landscape became the test. A terror bird was not terrifying because it was a monster. It was terrifying because it was real, and because evolution had taken something familiar and sent it down a path that feels almost impossible. To understand that animal, we have to begin where the evidence is strongest, not with a chase, not with a scream, but with bone. A skull tells a story before it ever becomes a face. In Kelencan, one of the largest known terror birds, the skull was enormous for a bird. Long, deep, and armed with a heavy hooked beak, it was not a delicate instrument. It was the front end of a ground predator. But the shape alone is not enough. The skull has to work. It has to resist force. It has to survive contact. It has to connect with a neck that can control it and legs that can place it in the right position at the right moment. This is where the terror bird becomes more than an image. Studies of related forms, including Endaugalornis, show why the beak was not just a threatening outline. The skull could be examined as a structure under stress. Models can ask where force would travel, which directions the skull tolerated better, and which movements may have carried greater risk. The answer is not a perfect killing machine. That matters. The terror bird's head was powerful, but power always has a direction. It was better suited to certain kinds of force than others. This suggests a predator that may have used controlled strikes, downward blows, precise head movements, and fast positioning rather than prolonged wrestling with the mouth. The neck mattered because the skull could not act alone. In a flying bird, the neck helps position the head in air, on branches, at the nest, or in feeding. In a terror bird, that same general tool was recruited into a terrestrial predator system. Range of motion was not just flexibility, it was tactical space, where the head could reach, how the beak could descend, how quickly the animal could reset. And then there were the legs. The legs are easy to reduce to speed. But for a predator, legs are not only about running fast, they are about stability, acceleration, turning, braking, and keeping the weapon aligned with the target. A ground predator is always negotiating with the surface beneath it. Dust, mud, loose gravel, riverbank sediment, dry grass, broken soil, all of these become part of the body's performance. So the terror bird was not a skull mounted on legs. It was a coordinated system, a bird body transformed into a ground predator. But every system has a world around it, and the world around terror birds was not empty. Ancient South America was not a stage built only for them. It held native ungulates, litopterns, note ungulates, armored mammals, small prey, large prey, reptiles, wetlands, dry open spaces, wooded corridors, and changing habitats. The terror bird's role had to exist inside that network. This is where the story becomes more complex than giant bird hunts everything. A predator does not dominate a world simply by being large. It has to match the terrain. It has to match the available prey. It has to survive its own mistakes. It has to drink, move, rest, reproduce, and cross the same dangerous places as everything else. River margins and wetland edges would not have belonged only to birds. Crocodylians were part of these ecosystems too. They were not background decoration. They were another kind of pressure. One fossil makes that point with unusual force. A leg bone attributed to a Phorusrhacid from the Venta region preserves marks consistent with crocodylian or caiman contact. The details are not a movie scene. They are not a clean answer to the question of who killed whom, but they are evidence of interaction. A notch, a groove, a damaged surface on bone. The safest reading is not that caimans routinely hunted terror birds. The safest reading is that the body of a terror bird, alive or dead, could enter the feeding world of crocodylians. It could be bitten, handled, scavenged, attacked, or drawn into the violence of a river edge ecosystem. That single point changes the mood of the animal. The terror bird was a predator, but not outside danger. It was not an invincible apex symbol floating above the food web. It was inside the food web. It could apply pressure, and it could receive pressure. In this world, even the predator left evidence of being touched by danger. The reason this matters is that evolution does not begin with a clean design sheet. It works with inheritance. A terror bird did not begin as a mammalian predator and then become feathered. It began inside the possibilities and constraints of birds. The beak, the neck, the pelvis, the balance over two legs, the lightweight but strong construction of the skeleton. All of these were inherited materials. The predator was built from what was already there. That makes the transformation more impressive, not less. Instead of imagining an animal that had every weapon at once, we should imagine an animal that had to solve a problem with a limited toolkit. No gripping forelimbs, no slicing teeth, no powerful mammal jaw, no flight-based attack once body size and ground life took over. The terror bird answer was not to become every predator. It was to become one very specific kind of predator. This is why the best visual story should not drown in diagrams. The diagrams are the clues. The living animal is the case. Every time we return to a skull, a map, or a figure, the question should be, what did this mean on the ground? In wind, dust, water, distance, and risk. The answer is always ecological. A skull in isolation is silent. Place it in an open habitat, in a moving body, near wary prey, near a river edge, and it becomes part of a decision. Does the bird close distance? Does it strike quickly and withdraw? Does it avoid a struggling animal too large to control? Does it take advantage of smaller prey, injured prey, carcasses, or moments of confusion? We cannot turn every question into certainty, but the questions themselves keep the reconstruction honest. This is also why the caiman mark bone matters so much. It does not need to become an action scene to be powerful. Its value is quieter. It reminds us that the ecosystem was not arranged as a throne for the terror bird. It was a field of overlapping dangers. The same body that could threaten another animal could become evidence on another predator's feeding path. A good predator story is not about invincibility. It is about pressure moving in more than one direction. Even the greatest terrestrial hunters are bound to water, terrain, injury, chance, and competition. A riverbank can feed a predator, hide a predator, or preserve the trace of a predator after the living moment is gone. That is the tone this film should hold. Not fantasy violence, but the memory of pressure. By the time we reach the end, the terror bird should feel less like a creature designed for a poster and more like a biological answer written into a specific world. The terror was not supernatural, it was practical. It came from a body that could move, strike, and impose risk until the world around that body changed the terms of the problem. That is the kind of detail that makes the animal real. It pulls the creature away from fantasy and places it back into ecology. A terror bird on open ground may have been a serious threat. A terror bird near water, near carcasses, near ambush zones, or in a contested ecosystem was part of a much larger negotiation. This is why the story of terror birds cannot be told only through their largest skulls. The skull is the signal. The world is the test. Across time, terror birds were not a single design repeated without variation. They were a radiation. What we call terror birds were not one frozen template stamped again and again across millions of years. They were a family of experiments. Different branches explored different sizes, different proportions, and likely different ecological roles, all within the same broad Phorusrhacid framework. That matters because it changes the image completely. Kelenken, with its enormous skull, is one extreme. It is not the whole story. Some terror birds were much smaller and lighter. Forms such as Psilopterus remind us that this lineage did not begin as a giant caricature. Other genera, such as Patagornis and Indalgolornis, help fill out the middle of the range, showing that the group included birds with different builds, different body proportions, and probably different balances of speed, reach, and prey choice. Then there were the classic large-bodied forms, including Phorusrhacos, and later the truly imposing giants such as Kelenken, where the silhouette approaches the image most people now carry when they hear the phrase terror bird. And then there is Titanus, the most famous reminder that this story did not remain perfectly sealed inside South America forever. The important point is not memorizing every genus. The important point is seeing the pattern. This was not one monster, it was a branching history. A family of predatory birds exploring multiple versions of the same evolutionary idea. How far a bird body could be pushed toward terrestrial predation. That is where the phylogeny becomes more than a chart. A branching tree is not just a diagram of names, it is a record of experimentation. One branch remains relatively small, another pushes size, another emphasizes a different proportion of skull to body, another occupies a different part of time and geography. The tree makes visible something the monster image hides. Terror birds were not a single answer. They were a cluster of related answers, and the same is true of scale. A lineup of these birds would not show one clean progression toward giant size. It would show variety, smaller forms, medium hunters, taller, heavier predators, heads becoming deeper and more imposing in some lineages, different bodies solving similar problems in related but not identical ways. That diversity is exactly what makes the group so compelling. A radiation can produce variety, resilience, and ecological reach for a time. It can test a successful design across multiple forms, but it also reveals something deeper. Every branch is still negotiating the same world. Every form is still bound by terrain, prey, competition, climate, and inherited anatomy. Diversity does not erase limits. It reveals how many ways evolution tried to work within them. So when we talk about terror birds, we should not imagine one perfect killer repeated over and over. We should imagine a family of ground predator experiments. Some smaller, some larger, some lighter, some heavier, all recognizably part of the same broad lineage, all working with the same basic bird blueprint, all pushing that blueprint toward predation in slightly different directions. And that is exactly why their later limits matter. Because extinction did not erase one design, it closed a whole family of experiments. Specialization is never free. A body that becomes very good at one kind of life can become vulnerable when the rules of that life begin to shift. If the prey changes, the habitat changes. If the open spaces close, fragment, dry, flood, or reorganize, the system is tested. If new competitors arrive, if climates move, if ecological corridors open, if the old isolation weakens, the predator's design has to keep paying for itself. The terror bird design was powerful because it was focused. The beak did not need teeth to be dangerous. The neck did not need to be monstrous to matter. The legs did not need to belong to a mammal to make a hunter, but the same focus that made the system work also meant it had boundaries. A bird body can do astonishing things on the ground, but it is still a bird body. It carries its own geometry, its own balance, its own limitations in how it grabs, holds, strikes, turns, and survives contact. This does not make terror birds weak. It makes them more interesting. The myth says, here is a giant killer bird. The evidence says, here is a specialized predator built from trade-offs. A skull can become a weapon, but only in certain ways. A neck can deliver force, but only through certain arcs. Legs can carry speed and weight, but only across certain surfaces. A landscape can support a predator, but only while the web around it continues to make sense. That is the hidden story of terror birds. They were not failed dinosaurs. They were not birds pretending to be mammals. They were not monsters that evolution forgot to stop. They were their own solution. For millions of years, that solution worked well enough to leave a record. Skulls, bones, tracks, comparisons, stress models, maps, and the strange traces of contact with other animals. Each piece is a clue, not a complete scene. The fossil record rarely gives us a full event. It gives us fragments that force us to reconstruct pressure. A skull tells us about possible force. A leg bone tells us about movement and risk. A bite mark tells us about contact. A map tells us about isolation and connection. A timeline tells us that no design remains outside history. When the world changed, the terror bird system had to face a truth that every predator faces eventually. Being dangerous is not the same as being permanent. The final disappearance of terror birds was not a single simple defeat. It was the end of a long evolutionary experiment. A world that had once allowed birds to become major ground predators no longer preserved that role in the same way. The stage shifted, the cast changed, the old solution lost its place. But extinction does not erase the experiment, it sharpens it. Because when we look back at terror birds, we are not just seeing a frightening animal. We are seeing evolution ask a question with bone, muscle, balance, landscape, and time. How far can a bird go if the sky is no longer the point? The answer was written across South America for millions of years, in skulls large enough to look impossible, in legs built for the ground, in traces of prey and pressure, in marks left by other predators, in a history that rose, diversified, endured, and finally disappeared. The terror bird was not terrifying because it broke the rules of nature. It was terrifying because it followed them. It was a bird shaped by opportunity, isolation, mechanics, and ecological pressure. It found a way to become a predator without teeth, without hands, without flight. It turned the front of the body into a weapon and the ground into a hunting problem. And then, like every evolutionary answer, it met the next question. The fossil is not just the remains of an animal. It is the boundary of a system, the place where a living design stopped moving, entered stone, and waited for another species to ask what it had been. Not a dinosaur, not a mammal, a bird. And for a long time, that was enough.